Thank you, everybody, and good morning. I guess, yeah, as Marty says, in this session, what we're kind of doing is starting off a whole series of discussions and presentations about RESTful web services. You're going to hear a lot about RESTful web services during this conference, and what I'm trying to do in this session is just set the stage a little bit. Some of you will be familiar with web services and in particular what RESTful web services are, but a lot of the people I know for a fact in the room are not doing RESTful web services yet. As Bill mentioned, we feel it's an important subject that almost all of you probably need to be thinking about and getting into and thinking about how this impacts your applications going forward. So this session is just going to be a brief introduction to web services generally. We're going to talk about what web services are, how they're built, a little bit of history, just to sort of make you aware of where this all started and where it all came from. And we'll talk about current technologies and why they're important to your business. So what are web services? Well, according to the World Wide Web Consortium, they define web services as software systems designed to support interoperable machine-to-machine interaction over a network. That network is usually the internet, but not necessarily. So web services essentially expose your data and/or your logic to something else remotely, usually via the web, or certainly by web technologies, HTTP and so on. Essentially, the best way to think of a web service is think of it as a remote procedure call. It's a piece of code somewhere out there on some server that you can interact with in order to access a piece of data or make something happen. It's a remote subroutine, essentially. Web services are not called directly by users in applications, they're called by other pieces of software, typically. So a website a user might use within a browser application. A web service is something that's consumed by a piece of software. And it's really all about publishing APIs. It's about exposing the functionality of a given piece of application software to other applications, other clients, other organizations perhaps, or possibly even the public. So how are web services implemented? Okay, so a web service is simply a combination of a piece of code that does something. It might cause some changes in your back-end systems. It might just expose a piece of data. That code is combined with some network protocol to allow access to that code from usually a remote system, and combined further with some kind of format or standard that's used to represent a piece of data that's being sent to the web service or received from the web service. Web services are coded using a programming language. Might be Synergy, might be something else. Almost all development environments are capable of creating and exposing web services these days. It's a very prevalent technology. And as I mentioned earlier, really they're just callable methods. So here's an example of a very simple web service. This is actually from an environment that we're going to be introducing to you tomorrow called Harmony Core. And here we have two methods, one called getCustomers that returns a collection of customers, and one called getCustomer that has a parameter, it accepts a customer number and it returns information about a specific customer. So that's two very simple, or an example of two very simple web service operations that would allow you to expose a certain type of data. Other operations might just take various parameters and take action in the back end and cause things to be created or updated. Here we're just exposing information. Writing the code of a web service is the easy part. The clever part is how all of the network messaging takes place, and how the call comes in and how the data is serialized and deserialized. And thankfully, most of the web services frameworks take care of all of that stuff for you. So even though we're dealing with HTTP and XML or SOAP or JSON data, you don't typically as a developer have to worry about those things. They just happen, and the framework will deal with them for you. Web service network protocols. Web services almost always use HTTP or HTTPS. Again, we're talking about internet usually. It could be local network, but generally we're talking about internet protocols. Almost always these days you want to be using HTTPS. HTTP is really not acceptable these days, and more browsers will refuse to interact with HTTP things. Search engines will not serve up HTTP things. That's more and more the case as time goes by. So you really need to be considering HTTPS is what you need to be using for web services. Occasionally web services use other network protocols. WCF, for example, might use sockets or some other network protocol internally, but a very, very high proportion of web services use HTTPS. In terms of the data interchange formats, In the early days, web services, the data interchange format was, there was something called Standard Object Access Protocol that was an XML dialect. It was quite verbose, but that was the typical way of representing data in and out of a web service. As time moved on, more plain XML became more common simply because it's lighter weight. But almost all web services these days now deal with something called JSON. JavaScript Object Notation is what that stands for. And this is what a piece of JSON data looks like. As you can see, it's a much more minimalistic way of representing the exact same piece of data. And obviously, the smaller we can make the representation of a piece of data, then the faster it's going to get, the less bandwidth it's going to consume, and the faster it's going to get transported over the network. So for its simplicity and its conciseness, JSON is pretty much the data format of choice for almost all web services these days. Why are web services used? Well, web services are used to really achieve interoperability between different applications. That might be two applications that you have control of. So it might be that you control the server application and you are building a client application and the web service is a mechanism that you use to interact between the two. Or it might be that you're just offering a service for use by third parties. Maybe you're exposing a web service to expose functionality to a business partner. Maybe you're selling functionality to whoever wants to consume it in the form of a web service. Web services are a great choice because they kind of give you the ability to do things that in days gone by we would have done with software components. You know, you'd have purchased an ActiveX control or a DLL to do something, but then you had to download that and install it, and there were configuration issues and dependencies and requirements. Web services are pretty much platform and language agnostic. You can pretty much call them from anywhere, interact with them from anywhere. It's just HTTP, and it's ASCII values representing JSON data. Any development environment can cope with calling web services. They're also decoupled. As a client developer, you don't need to know anything about how a service was implemented, and vice versa. You don't know what the clients are. You don't care what the clients are. You just develop and operate the service and document it, and anybody can use it. Subject to you allowing them to use it, possibly. Doesn't mean it's available for the world to use. Web services also, if they're implemented correctly, can be very, very scalable, and generally they're just a great return on investment, because one of the main points of a web service is you implement it once and you expose the functionality of your application, and you can then use that very same web service from any number of clients. And as user interface requirements change over the years, and we all know that UI changes on a regular basis, there's no need for the back-end service to change. You just build new thin clients that talk to that web service. Categories of web service. What are web services used for? There are really three main categories. Some web services are used to build public APIs. So by the nature of the term public API, you can imagine it's available for use. You're either providing maybe a public information service, maybe you're selling that information service to other people, maybe it's something that's for free. A public API might also be something that perhaps supports a mobile app that's available through an app store. So you might have a public API web service that provides the back-end functionality that web or that mobile application interacts with. So public APIs tend to be open to anybody, potentially at least. They often do require registration and authentication and perhaps payment on frequently as well. So just because they're public doesn't mean they're free. They might be still restricted access, but anybody could get to them. And the connectivity with a public API clearly is generally they're communicating over the internet. Frequently, web services are also used for what I tend to call restricted use APIs. So here you might be talking B2B, interaction with partner organizations, vendors, customers, that kind of thing. Maybe exposing a specific API to achieve a specific business goal with a specific partner. Not necessarily, it might be a more general thing, but with a restricted use API, you're generally talking a limited and known audience. You're still probably talking about internet communications, but like I say, typically apps or APIs designed to achieve a specific integration with a specific partner, or perhaps a specific integration with another application that you use within your business. And then private APIs. Private APIs are, it's the same technologies. This is really just a case of how it's deployed, what networks are used, how accessible it is. But typically supporting things like corporate websites, doing systems integration between internal applications, not necessarily internal, it might be still across the internet to other parts of your entity, but private APIs tend to be totally restricted use, internal, highly controlled who can access them, and the connectivity might be internet or might be private networks only. Very often private APIs are highly specific to a very specific purpose and not general purpose like public APIs would be. History of .NET web service technologies, very briefly, things in the .NET world where most of us live if we're doing this kind of stuff. Although there are, you can build web services on Linux and VMS systems and stuff like that. People in the room have done that. But in the .NET space, which most of us tend to gravitate to when we're doing this kind of thing, we've had web service support since .NET 1.0. Back in 2002, they used to be, if you look out for URLs ending .asmx, that was the original ASP.NET web services technologies. They always used HTTPS. They were totally based on SOAP as a data dialect. And back in the day, they gave us some great functionality, but I think there's possibly one or two of you in the room still using some ASMX technologies, but pretty much they've all been replaced at this point. Then along came Windows Communication Foundation. I know for a fact there's still quite a few of you in the room using WCF type technologies. That was introduced with .NET Framework 3 back in Visual Studio 2005. We all think of WCF as kind of a recent thing, but actually it's kind of old now. It has not been updated in any significant way since Framework 4.5 in Visual Studio 2012. So WCF has kind of fallen by the wayside in terms of new development, still very much heavily used. One of the nice things about WCF was you could use HTTP or TCP or named pipes, all these different protocols to get really high performance on internal networks. It was still pretty much SOAP based, so XML, very, very verbose XML. And it was heavily configuration based, which meant it was very easy to write WCF code, but it was a nightmare to configure it and get it running on systems and manage all the endpoints and all of that kind of stuff. It could be very fast, but scalability was often a big problem with WCF as well. In recent years, things have moved on, and now the state of the art is something called ASP.NET Web API. We talked about Web API a lot at the previous conference last year. Web API was introduced in .NET Framework 4, so Visual Studio 2010. This is not latest and greatest stuff, or current versions of it are still latest and greatest. But it's totally focused on building what we call RESTful web services. Now, I'm going to go on to explain what that means in a moment. The point about RESTful web services is they are incredibly easy to learn how to build them, they are incredibly easy to build, and they're incredibly easy to use. And if designed well, they are incredibly fast as well. It really is the state of the art for how to implement any kind of web service these days. A very high percentage of public APIs, I think it's in the order of 75% of public APIs today are implemented as RESTful web services. And that trend, we think, will continue well into the future. So, RESTful web services. What is RESTful web services all about? RESTful web services, when you hear that term, it's important to understand, well, it stands for Representational State Transfer. And RESTful web services is not a specific product or a specific technology. RESTful web services is something that could be implemented in pretty much any environment. It's an architectural style. It's a set of guidelines for how to go about implementing web services in the modern software development world. So RESTful web services are essentially a set of constraints, a set of guidelines. You might want to call them suggestions instead of guidelines. Not all of them are mandatory. It's a way of going about designing things so that you expose things in a uniform way. So all RESTful web services tend to look very similar in the way they present themselves and the way they work, and also importantly in a stateless way. So one of the core fundamental things about RESTful web services is it's a stateless environment. You make a call, something happens, you're done. There's no state being maintained. So architectural goals of RESTful APIs and why they've become so popular are they are all about being accessible from any environment, from any platform, from any location, and so on. They are by nature simple through the use of a uniform interface. As a developer, if you've ever interacted with a RESTful web service, you could probably go to pretty much any other RESTful web service and have a pretty good idea of what it is and how it works and how to use it without even looking at the documentation. They all present themselves in the same way. And again, an architectural goal is performance and scalability. RESTful web services rely heavily on various other standard things, and the three main ones are listed at the bottom of the slides. So they rely heavily on the use of URIs, or URLs if you want to call them that. We're familiar with URLs as we type them into a web browser. That's a URI. So URIs are very important in the RESTful web services world. They identify what it is you're trying to access. HTTP, the protocol of the web, is heavily involved in RESTful web services, and you'll see how as we go through, and also JSON. RESTful web services sometimes serve up XML data if you wish. Some of them will do both optionally, and as a client developer you can choose which you want, but almost always the default environment in a RESTful web service is accepting and responding with JSON formatted data. So consistent interface and standard operations. URLs are used to identify the type of operation and what it is you're trying to access, and I'll show you some examples of this in a moment. In RESTful web services, the HTTP methods that are used, and if you're not familiar with HTTP in depth, when you type a URL into a browser, that is called a GET request. A GET request only involves a URL, okay, and some response comes back. There are other methods like post and delete and patch and put and various others that HTTP has that are heavily involved in RESTful APIs. And as we go through sessions during the conference, you'll see much more detail about how this works. Inbound data is passed to a RESTful web API in one of two ways, quite often a combination of the two. Some parameters might be specified as part of the URL, or data is provided in the body of a request to the service. Outbound data, if any, is passed entirely through the HTTP response body, just like when you type a URL into a browser, you get a response with HTML data in. Web services, RESTful web services work the same way. And also HTTP has a completion status. You might have found that if you get a URL wrong, you get a 404 error in your browser. 404 is HTTP speak for not found. And there are lots of other response codes that indicate various things. And again, RESTful web services inherently use those HTTP response numbers to indicate did it work, did it not, was something created, was something not found, did you not have permission, all kinds of things are indicated by those HTTP response codes. URLs identifying entities that you're being addressed. Here's some examples. So a RESTful web service tends to have a base URI. So here it's services.domain.com/API. So that will be the URL at the beginning of every request to the service. It's like the service home address, if you like. And then /customers would say, I want to address data about customers. /customers /12345 says, I want to address data about a specific customer. Okay, and we might do GET requests to retrieve that data. You might have a URL that's customers state California. It's saying I want to access customers, but only those customers in the state of California, and so on. So that's how URLs are heavily used to identify the type of operation, what is it you're trying to access. And all RESTful APIs basically work the same way. HTTP methods identify the operation type. So a GET on a URL is basically retrieving something, reading something. And we've seen a couple of examples there. It might be a collection of something, or it might be a single specific something that's being accessed. A post operation, on the other hand, and a post is typically what happens if you fill out a form on a website and hit submit. That's typically a post operation. And a post operation involves sending data that was in the form to the server in a request, and then you get a response back as well. So a post operation tends to be used to create something new. Okay. In modern RESTful APIs, a post is typically used to create something where you're not responsible for picking the ID of whatever it is. So you're going to create a new customer, but you don't provide the customer ID. That gets automatically selected on the back-end system, perhaps. A put is typically used to replace something. That might involve updating an entire customer, for example, or it might involve creating a new one if it doesn't exist. Put can be used for both. There's also an operation called patch that's heavily used in RESTful APIs, and a patch allows you to do a specific update. So maybe you're updating a customer, but all you're changing is the phone number field. And it's a very efficient way of doing that. And delete, obviously. It's fairly obvious. You'd be deleting a specific type of entity. So data is passed via the request and the response body. So an example of data for a get, a post, and a put might look something like that. We literally just got a piece of data, a piece of JSON data that represents whatever the entity is that is passed via the HTTP body. And if you haven't come across patch before, it's kind of new to a lot of people. That's what a patch document looks like. So it's a JSON array of specific instructions. Here we're saying replace the street field with a new address, replace the zip code with that. So it's a targeted specific set of updates to an existing entity. Completion status, we mentioned some of these before. We don't need to go through all of these in details, but you're all familiar with 404, and like I say, there are other statuses that represent, yes, it was successful, nothing was returned, something was created, there was a bad request, there was a serious error, that kind of thing. So there's an example request and response, and you can see that this is a typical here we're doing a post, so we're creating something. It looks like it might be a purchase order. We've got an account number, a PO number, an array of items. So we're posting this to a server, to the base address acme.com API orders, and we're getting a response back, 201 created, and it's given us the URL where we can access the new thing that we just created. That's a typical RESTful API, and you can see it's very efficient. That's the extent of the data that's going to go over the network. It's and the response in particular is very brief. It's a tiny little message that just says, yep, it worked. Okay. SOAP, if you think back, if you've ever done SOAP web services in the past, you'd have had several hundred characters of SOAP bodies and SOAP envelopes and SOAP responses and response codes and all of that kind of stuff, and it's a lot more verbose and therefore slower. So advantages of RESTful web services, they're simple to learn, use, build, operate. They are very open, it's just HTTP and a very common data format, which is JSON, and they can be, like I say, you can interact with them from pretty much any software environment. If it's reading data, you can access with the service in its entirety just by typing URLs into a browser. It's really that simple. They are more standardized because of the way that RESTful APIs use URLs and use standard protocols like HTTP. One is very much like another. If you've used one, you know how to use them all. You need to know what the operations are and so on, but you know how to go about it. They all work in the same way. And because they're stateless, they're also very, very unit testable as well. So RESTful APIs are great for building test environments, or building test environments for. So ASP.NET Web API is the underpinning technology that you're going to hear us talking quite a bit about at this conference. Web API is an open source framework for building RESTful web APIs. So there's no SOAP involved in Web API, there's no WSDL files, it's HTTP only, and there's a strong preference for JSON data, although Web API does support XML data as well if you really wish to do that. If you've ever done any website development with Microsoft's latest tools, the ASP.NET MVC, then you'll be instantly familiar with Web API because it's based on very similar technologies with models and controllers. There's just no views involved in web services. Web API heavily uses convention over configuration. So what that means is there are rules for how you name things and conventions for how things are named. And if you follow those rules, then things just happen for you and you don't have to configure things. So if you ever dealt with the nightmare of configuring WCF endpoints, all of that stuff just goes away in a Web API RESTful environment. They're easy to learn and use, great performance, and if you've ever done ASMX type web services or WCF web services or any other SOAP-based environment, then you will very quickly realize that RESTful APIs and Web API in particular is a huge step forward. So there's something else I want to briefly introduce you to. Jeff is going to tell you a lot more about this tomorrow, and so am I in subsequent sessions. But just to make you aware of something, if you're not already, there is something out there called OData. OData stands for Open Data Protocol, and currently we're talking about version 4 of the OData standard. So OData is an open protocol that it's a way of going about exposing and creating and consuming web services in a way that they are queryable and interoperable and useful in a lot of different ways. So initially, OData was a Microsoft thing. And that, as soon as some people, if you're familiar with it, hear OData, oh, that's that old Microsoft thing that never really went anywhere. Yes, it was originally, and it didn't really go anywhere for quite a number of years. But now OData is an open source technology. It's managed by, well, Microsoft is still involved in it, but it's managed by an external team group of organizations, and it's very much an industry standard. And what OData does is take RESTful web services to a whole new level. It allows you to query into data, essentially. So if you imagine that URI that we talked about earlier, apis.myorg.com/API/customers. Okay, so I'm saying, I'm exposing my customer data at this URL. Okay, what OData lets you do is drill down into that data in many, many, possibly hundreds of different ways, depending on what you want to do. So with OData, what you can do is, in the URL, you can use keywords like $select. $select allows you to say, I'm accessing customers, but I only want to see the customer ID, the name, and the account balance. So don't send all of that customer data back to me. Just these are the only products, these are the only pieces of data I want. $filter allows you to restrict the rows that come back. So you might $filter on only customers in California who have an account balance of greater than $6,000 and haven't made a payment in 30 days, or something along those lines. All just driven off that one customer's endpoint, okay? You can use things like top and skip to do paging. You can use $count to say, I don't need all the customer data, just tell me how many there are, or how many orders does this customer have, and that kind of thing. You can also return individual properties. So maybe you're in a mobile app and you just need to get the name associated with a customer account. You don't want to get the whole customer, you just want the name. Things like that. You can also drill into relations with OData. So it's extremely powerful. If you set up your environment properly so that customers maybe have orders, right? And those orders have items that were ordered. Each of those items is associated with a piece of inventory. And that inventory comes from a certain vendor, right? That's the example from our sample data set. With OData, just because you've exposed customers, you can now drill down through all of those different related pieces of data without programmers having to write specific endpoints and specific methods to say, get all of the customers' data orders. You've got customers, there's a related orders property, and you just drill down into it. So it really simplifies the entire environment and is extremely powerful. Here's an example of a query. Look, we're doing customers, filter, state equals Nevada, select equals customer number and name. So we get back all the customers in the state of Nevada, but we only get back their customer number and name. Well, we get the E tag as well. E tag is something that Jeff will talk about. Essentially, it's similar to a GRFA. It's used for optimistic concurrency. Okay? So OData is extremely powerful. There's another example. We're saying customers, all the ones whose state is California, credit limit greater than 5,000, and only return customer number and name. Very powerful. No specific function written to do that. We're just exposing the customer's endpoint and then using OData to query it. It's kind of like SQL for web services. You know, you get to group and order by and filter and where and all of that kind of stuff. Here's a really powerful example of what I was talking about a few minutes ago of drilling down. So here we're accessing a customer's endpoint for, OData uses parentheses for parameters, by the way. So we're saying here we want to access customer 8, and all I want to see is their customer number and name, but also I'd like to see all of their orders. And all I want to see from the orders file is order number and date ordered. Also, I'd like to drill down into the items on those orders and show item ordered, quantity ordered, unit price, and let's drill down into the actual inventory and get the name of that item and its size. And so that you can see clearly. And also, you can also filter and order by and at all of these levels. So you can build extremely complex queries that really do allow you to get really powerful, specific access into your data, again, without writing specific code to do these things. It's like SQL for web services, essentially. Why are web services important to your business? Well, as Bill mentioned earlier, a lot of you guys are involved in building new UI these days. So standalone monolithic applications are really no longer the way of going about things for many people. So most organizations these days also use applications on multiple platforms and perhaps applications from multiple vendors. So web services is a great way of interacting and integrating between those applications. Web and mobile apps are obviously becoming more and more popular and more important to a lot of your business. And web services is the way to service those applications and those websites. Performance and scalability are really important to a lot of you as things get bigger and the number of users increase and organizations grow. RESTful web services in particular are extremely high performance when compared to other older technologies. And also software development is an expensive thing to do. And the concept with a RESTful web service is you develop something once, you expose the API once, and then you can reuse that investment from your mobile apps, your web apps, your corporate desktop apps. Everything is driven by that one back-end service. Why the big focus on RESTful web services at this conference? Again, as Bill mentioned, enhancing user experience is very important and is a project that a lot of you are either already engaged with or interested in getting into. And the best way of achieving that is to refactor your application into a black box processing engine exposed via RESTful web services, so you only have to do that work once, and you expose that API, and then you layer your new client application or applications. Very often it's mobile and some other kind of application, web or desktop as well. So fewer Synergy developers are using Synergy tools to build UI, but more and more Synergy developers these days are using web services technologies to transform their applications into an API. Really, the way I look at it is, in most cases, for most of you in the room, the server really is the application, and the client applications are just platform-specific views onto that business logic and onto that data. And that's essentially what web services allows you to do. Also, while text-based user interfaces and toolkit are no longer popular, a lot of you have huge investments in the code base that you've built up over the last 10, 15, 20, 30, 40 in some cases years. And it is very possible to transform that data and restructure that data or that code and expose it as a set of RESTful web services. And Don's team in particular do that on an ongoing basis. They've helped many of you in the room restructure your code in that way, and it's certainly a very doable thing. Very briefly, this is just really a teaser because we've got something we're going to be introducing to you mainly tomorrow. So Jeff is going to introduce you in one of his sessions tomorrow morning to something called Harmony Core. So what Harmony Core is a web services framework that allows you to build and expose RESTful web APIs that expose your Synergy data and your Synergy business logic in new and exciting ways. Harmony Core is available as binary packages, so you can just add a reference to various NuGet packages and get it up and running in your environment. It is also open source, so if you do want to download and clone the source code and build it yourself, you have the opportunity to do that. It really consists of some binary code in our NuGet packages, a bunch of code gen templates. So Harmony Core heavily leverages code generation technologies to generate these web services for you. And like I say, everything's open source. Harmony Core is totally based on industry standard things that are also all 100% open source, okay? So we're building on top of ASP.NET Core Web API. OData, we mentioned a few minutes ago, we're building on top of OData Core. Entity Framework, so Jeff's going to tell you about a new entity framework provider that we've created for Synergy that is at the heart of what the Harmony Core framework does. And we're also leveraging .NET Core Identity. So we do authorization and authentication and roles-based stuff and claims-based permissions and all of that kind of stuff. So totally based on standards. It allows you to do highly efficient web services development. In many cases, in fact, the workshop on Friday, we won't actually be writing any code. We'll be generating based on our repository and our ISAM file and relative file definitions, basically generating the entire environment. And for many of you, if you've already got a well-defined repository database, you will be able to do the same thing in your environments exactly the same way we do on Friday. And you can potentially be up and running with RESTful web services very quickly. Also, we've had a big focus on making it fast and scalable. There's still a little bit of work to do there, and again, Jeff will talk more about that in his sessions, but this is an extremely high performance environment as well. On that note, I mentioned at the beginning of the presentation that this was really setting the stage for things that are to come. So we are talking about .NET Core in this environment, and I realize that some of you may not be totally familiar with what .NET Core is. So there's a session tomorrow morning where I'm going to explain what the difference is between .NET Framework and .NET Core, and what's .NET Standard all about, and how do all these things fit together, and how are they used. Then Jeff's going to introduce you to the Harmony Core open source project. Jeff will then drill into a little bit more detail about some of the internals and talk about the entity framework provider. I'm then going to come back and give you some specific information and demonstrate exactly how Harmony Core development works towards the end of the day tomorrow. And then the post-conference workshop is all going to be totally about building RESTful web APIs for an existing little sample environment using Harmony Core and using CodeGen and all of those tools. So with that, are there any questions? Does OData require extremely specific keys to be set up for the queries to work, or that the queries run efficiently when searching for non-keyed fields? Yes and yes. In order to be most efficient, then the ideal scenario is that your repository defines all of your ISAM keys in detail, correctly and accurately, mapping all the segments correctly to fields and doing things in the right sequence and so on. So yes, if you have keys defined, that is a definite advantage. We also take all of the alternate keys and expose them as specific endpoints as well. So you can drill into the data directly via the state code or the whatever. If alternate keys are present on the file, you can definitely leverage that information. What's really important, well, it's not important, you can get away without it, but what really enables a lot of the power of OData is not only defining the keys, but defining the relationships. And that's where a lot of you may not have that information in the repository. If your repository was initially set up back in the day to support Report Writer, or if your repository's been well set up to support XFODBC, then you probably have all the keys and relationships in place, and you're probably in great shape to start using Harmony. But if you don't have all of your keys defined or all of your relationships, that's the work you'll have to do. Harmony Core will still produce web services, even if you don't have those in place, but you will just get more power if you have those things in place. Okay, great, thank you. Enjoy your lunch.